Hello everyone and welcome to my first devlog of my indie adventure game. It's been a while since I've finished something, so I finally decided to create a full game. The idea is to make a game that's extremely user-friendly and easy to play, even for a casual player. The game is going to be a simple adventure game with puzzles and some simple platforming. I'm not planning on making a combat system, but that doesn't mean that there won't be some kind of boss fights. The bosses will just be a harder puzzle that you have to solve in order to defeat the boss. I want the game to be smooth and I wanted the character to have realistic movement. Unfortunately, that wasn't entirely possible with the Unity character controller since it's not too good. So I've decided to create my own custom controller, which isn't a simple task, but it was a necessary task. Finally, after a week of hard work and lots of trial and error, the controller was finally done. It supports slopes, stairs, sliding, and most importantly, it can handle the smooth, realistic movement I had in mind. I've even created an inverse kinematic system that makes everything look even smoother. As you can see from the footage, the character has inertia. After you release the input keys, the character takes a few more steps before stopping. He even slows down when trying to turn around. At this point I was already really satisfied with the system. But that wasn't enough. I wanted the game to feel and look great, so I started implementing different systems. The first one is the ground system that can simulate sand, snow, mud, water, and even thick slime. It's a very heavy system and didn't run well on my PC. I'm using a wooden PC, hell, I'm still using one of those old hard drives. The system was running on about 5 frames per second at full HD resolution. But I couldn't give up. I had to optimize it. And so I did. But first let me show you some footage. This footage is running at 4 times the speed to show you how large the map can actually be. At this point you might be wondering, well, how does this even work on a wooden PC? Well, it's because I've implemented 2 systems that allow it to run on potato hardware. The first system is some simple terrain stitching. The second is something I like to call dynamic tessellation. Only tessellate specific parts of the terrain that actually require tessellation, and a small area around the player to stop a few glitches that occur due to my system. But what about foliage? Well, I used the same system with minor tweaks. I'm using a geometry shader to render the grass, and the logic of the deformation is pretty much the same, just applied on the grass. Before I finish, I want to mention a few things. I got asked about some of my system via email. People were wondering if this works with the universal rendering pipeline and shader graph, and frankly, I have no idea. I'm not using any rendering pipelines, nor do I use shader graph. I'm using the built-in Unity renderer. Actually, I'm only using the renderer and some of the physics because I don't like using pre-built stuff. Thank you for watching. Like and subscribe if you like my content and want me to continue making more videos. I'll probably make another devlog in about a week when I fix some stuff and implement more systems. Cheers.